So we'll just cover some problems to help you to get familiar with the notations which we used for permutations of distinct objects, especially without repetition. That's what this notation stands for, permutations of distinct objects without repetition. So this problem is basically to find the value of n such that np5, we call it like np5, that's how we read it, permutations of n objects taken 5 at a time, n distinct objects taken 5 at a time without repetition. That's what this notation is equal to 42 times np3, where n is greater than 4. And in the second case, you just have this expression np4 in the numerator, n minus 1 p4 equal to 5 divided by 3. Again, n is greater than 4 and we have to find the value of n. So you should be able to use the formula in the factorial notations on both the right hand side and left hand side, and then be able to solve for n for the first part and also for the second part. So I'll just give you the choices. The choices are 20 and 10, 5 and 10, 10 and 10, 10 and 20. So the answer is 10 and 10. Let us try to solve this problem now. So the first one was np5 is equal to 42 times np3, right? So then we are given this and we have to solve for n. So given that I will use the factorial notation, what is np5? It is n factorial divided by n minus 5 factorial, right? So you should just get familiar with how to write this formula more and more, and then you will be very comfortable with it. So this side is 42 times n factorial divided by n minus 3 factorial, right? And then generally when we try to keep on going to next steps for this equation, we just use this implied sign. So from this it implies that n into n minus 1 into n minus 3, n minus 2, n into n minus 3 into n minus 4 is equal to 42 times n into n minus 1 into n minus 2. So how is that? You just actually, I won't go into the steps, you should get used to it. Basically n factorial is n into n minus 1 into n minus 2 n minus 3 into n minus 4 into n minus 5 factorial, and the n minus 5 factorial will cancel, and similarly n minus 3 factorial will cancel, and you will be left with n into n minus 1 into n minus 2, right? So now we also have this condition that n is greater than 4, right? So if we have on the left hand side n and n minus 1 and n minus 2. Here also we have n and n minus 1 and n minus 2, right? So we can cancel or divide both sides by n into n minus 1 and n minus 2. Why can we do that? Because we know that is not equal to 0, because we are not allowed to divide by 0. Why is that? Because n is greater than 4, and this can be 0 only if n is equal to 0 or n is equal to 1 or n is equal to 2. But we know that n is greater than 4, so n cannot be 0, 1 or 2. Therefore we can divide. So we dividing both sides, we are left with n minus 3 into n minus 4 is equal to, so this is equal to 42, right? So we just multiply this left hand side, so this implies that n square minus 7n plus 12 is equal to 42, and then we have n square minus 7n minus 30 is equal to 0, right? It's just about, this basically involves solving quadratic equations. So quadratic equations, because you have the highest power of the polynomial in n is 2, so you just have to solve this quadratic equation for n, right? So there are two ways to do it. Certainly I will just factor it out. I'll use the factorization approach, but there is that quadratic equation formula where you have the two roots as, if you remember, you should revise it, but I'll just write down the formulas. B square minus 4ac by 2a will be the two roots of a quadratic equation, and you can always look back and see the quadratic equation which is of the form, I'm just writing in terms of n, so an square plus bn plus c equal to 0. So you can use this formula, but the other approach is use factorization, so I'll just use that. So I'll just use 30 being product of, minus 30 is the product of 10 and 3, and you can break minus 7 like that, so you'll just break this as 10n plus 3n minus 30 equal to 0, and then you can just say n minus 10 plus 3 n minus 10, and you have n plus 3 and n minus 10 is equal to 0, and n is equal to 3, n is equal to minus 3, or n can be equal to 10. But n equal to minus 3 is not possible because n cannot be negative, because you already know that n is greater than 4, so only solution available is n equal to 10. So we already solved the first part. Now we go to the second part. For the second part, similarly, we just look at, given that we have np4 divided by n minus p4 equal to 5. Sorry, this is bad. So 5 by 3, where n is greater than 4 as before. So now we just try to solve for n, right? So I'll just cross multiply things, these two and these two numbers, so that it's a little bit easier. So I'll just have np4 so 3 times np4 is equal to 5 times n minus 1 p4, right? So what is np4? So you should be accustomed to writing the formulas now. So it will be n factorial divided by n minus 4 factorial, whereas this is n minus 1 factorial divided by n minus 1 minus 4, right? So that is n minus 5 factorial. So again, just try to cancel what is common, and you will be left with 3n into n minus 1 into n minus 2 to n minus 3 here, and here you will be left with n minus 1, n minus 2, n minus 3, and n minus 4. Sorry, this I can't fit it in one line, that's why I had to just put it in the next line, but this is the product. So yet again you can see that n minus 1, n minus 2 and n minus 3, they are common to both sides, and you can divide by n minus 1, n minus 2 and n minus 3, because again n is greater than 4, so n minus 1 to n minus 2 into n minus 3 cannot be 0, because for it to be 0 n has to be either equal to 1 or 2 or 3, but n is greater than 4, so that's not possible. So what are you left with? You are left with 3n equal to 5n minus 20, right? You just multiply 5 with n minus 4. So if you solve this, it will be 2n is equal to 20, and this implies that n is equal to 10. We get the answer n equal to 10 for both first part and the second part.